Hello, my name is Rahul Singh and my matrix number is A182835. Today I and my friends are going to present our project called Our Support. I'm going to start by presenting the project background. There are a few types of sonar technology used by a ship. Sonar technology is mainly used by ships to detect depths of water, measure the speed of the ship, detect objects underwater, and map the seafloor. However, for some of these purposes, such as mapping the seafloor, detecting objects underwater, and the depth of water, the sonar technology is not required to be used during the entire ship's journey and it can be used one at a time based on specific priority from time to time. This will help to reduce noise pollution in the ocean. Hence, to aid in the efforts to reduce noise pollution in the ocean, we have invented the Autonomous Sonar Pollution Regulator, AUSOPOR. AUSOPOR is a device that will act like an underwater traffic light that controls usage of sonar technology by ships in its 10-kilometer radius. There are five main active components of AUSOPOR. There are the antenna, inertial navigation system, ultrasonic sensor, ballast tank, and Raspberry Pi Model B, which is an onboard computer. The antenna is used to receive and transmit radio signals from and to ships in its 10-kilometer radius. The type of radio wave used is very high frequency radio wave, which has a range of 40 nautical miles. These radio signals are used to receive the ship's identification number, the purpose of their sonar technology usage, and also the status of their sonar technology operation. The data received is then sent to the Raspberry Pi to be processed by the sonar usage priority sorting algorithm that will decide which ship is allowed to use its sonar technology first based on the importance of its usage purpose. On the other hand, the inertial navigation system is used to adjust the position of Alsopon underwater if there are any shifts in position. This process is completely autonomous and is controlled by the automated positioning algorithm. The data collected from the initial navigation system is sent to the automated position algorithm where it will be processed and used to control the sailplanes, rudder, stern planes, and propellers motor of our support. In the meantime, the ballast tank is controlled and operated by the surfacing algorithm that works together with the automated positioning algorithm to surface our support every 15 minutes to 2 hours depending on the traffic condition to receive radio signals from ships and update its location using GPS. The surfacing time interval is optimized by the surfacing algorithm using the data it receives from the antenna. Lastly, Alpha can detect the magnitude of ultrasonic wave in its surroundings by using its ultrasonic sensor. The data received from the ultrasonic sensor is then sent to the sound wave identifying algorithm, where natural and artificial ultrasonic sound waves are distinguished from one another. These data are then sent to the safe level checker to check if the magnitude of artificial ultrasonic wave is safe for aquatic organisms. If the magnitude of ultrasonic wave is above 150 decibels, it is considered unsafe and the data sending algorithm is used to control the usage of sonar technology by ships by using the data processed by the sonar usage priority sorting algorithm. The data sending algorithm transmits its data to ships using radio signals transmitted by ALSOPOR antenna by triggering the surfacing algorithm to surface.
Hi, my name is Imran Syukri bin Mohamad Shani. My name matric number is A1828CC. Now I will briefly explain about our objectives and the problem statement. For the problem statement of our project, first I would like to share the definition of ocean noise pollution. This type of pollution that is made by human activities that interfere with or obscure animals' hearing natural ability in the ocean. Most marine creatures rely on sounds to survive, particularly marine mammals and fish. Human activity has caused a lot of damages to the environment on land, also in the ocean. For example, shipping, recreational boating, military activities, and energy exploration of coast, offshore, and deep ocean environments. These activities have increased the noise level in the ocean and give a negative effect on ocean creatures and the ecosystem. Now, I will continue on the objectives of our project. Our first objective is to create a device that could help the researcher regarding noise pollution, then to identify natural and unnatural waves in the ocean, lastly, to create a device that can record the ultrasonic waves from the ship and transmit the data as radio waves to the ship. For the material of our supermodel, the scale is 1 unit equals to 1 centimeters. For the top view, the height of the model is 104 units and the width is 20 units. However, the length for the safe planes on each side are 10 units. 3 receiver antenna and 1 transmitter antenna are 1 unit radius each. For the length of the propeller is 14 units and stern plane is 11 units. Furthermore, for the front view, the radius of the pitch circle is 10 units and the height of the models are 45 units. The radius of the propeller is 10 units. In addition, based on the side view, the length is 104 units and the height is 45 units. For 3 receiver antennas, the height of each antenna is 10 units. Meanwhile, the height of the transmitter antenna is 15 units. The thickness of each safe lane are 3 units. The diameter of the connector is 1 unit. The height of the body is 20 units.
Hello guys, today I would like to talk three things in our project, ASOPO, Autonomous Sonar Pollution Regulator. Okay, here is our 3D design project. The main purpose of this project is to identify natural and unnatural waves in the ocean and to record the ultrasonic wave sonar from the ships and transmit the data as a radio wave. The design for our model is submarine because this design is created for underwater self-propelled craft and built to perform underwater operation for a stipulated amount of time. So next, here is our astrometric drawing. Okay, here is our assembly drawing. Firstly, we have a ballast tank number 1 in our project because it has made sure that our submarine will be floated. Next, the body number 2 is to cover the batteries, motor and INS for our project. We have sailplanes number 3 in this project to use buoyancy control and lifting surfaces to travel in sawtooth trajectory through the water column. Next, we have sail number 4 to act as vertical stabilizer underwater and to protect our circuit and ultrasonic sensor. Batteries number 5 are generated to give energy to our motor and circuit. We have 3 circuit number 6 which are to detect the wave. We have 3 receiver antennas number 7 to use to receive the natural and unnatural wave in the ocean. Besides, we have 1 transmitter antenna number 8 to transmit the data as radio wave to ship. We also have a motor number 9 to move the propeller to make sure that our device is in static condition. Next, we have propeller number 10 to move our project when it spins. Next, connector 11 is used to connect our propeller to our rudder and stern planes. Besides, rudder and stern planes 12 are used to stabilize our project in the ocean. Rotary Inertial Navigation System or INS number 13 is used to detect our project in the ocean. Lastly, an ultrasonic sensor number 14 is an electronic device that measures the distance of a target object by emitting ultrasonic sound wave and convert the reflected sound into an electrical signal. That's all.
Hi, my name is Mohamad Aizuddin bin Ismail. My matric number is A182981.
Moving on to the electrical part of our project ASOPO. Since our main purpose of this project is to receive and transmit signals to ship, we are focusing our electrical part on the circuits of receiver antenna and the transmitter antenna. For the circuit of receiver antenna, it can be used with any frequency band. How the circuit works? So we use MPF102 as one of our transistor, as it can amplify high frequency signals very well. Next, the transistor Q2 acts as a load with high impedance to Q1, which is the MPF102. Meanwhile, it drives the input with low impedance to Q3. Q3 is a signal amplifier where it amplifies the voltage gain of the incoming signal. The important parameters of Q3 is the voltage drop across the resistor R8, where the higher the voltage across R8, the greater the gain. Lastly, the transistor Q4 will act as a linker or intermediary for modifying the high impedance output of Q3 to drive the signal to the radio receiver. Next, for the transmitter antenna, the circuit has 3 main stages. The first one is the input stage, where the circuit receives the data from Raspberry Pi. Next, the oscillation stage is where a carrier signal is generated and will be modulated by the signal from the previous stage. Lastly, the emission of the signal is done by the antenna. The modulated signal is fed into the antenna and then it will transmit the signal generated by the current as it oscillates.
To conclude, there are a few advantages and disadvantages for our project. For advantages, firstly, Asopro is fully automated, has no manpower is needed to operate it. Next, Asopro has VFH, radio wave, and their advantage is it has fewer sources of interference, both natural and man-made, and also has a high bandwidth. For this advantage, one of it is that it is battery powered. Thus, its power source has to be charged or changed from time to time. Besides, Asopro is unable to receive radio signal underwater, so it has to surface over a variable period.